Hey there, Science 2 kiddos. I'm going to use these slides to walk you through content from Hewitt, Chapter 26.8, all about water in the atmosphere, specifically clouds and precipitation. First concept you need to kind of wrap your minds around is the idea of relative humidity. It gets that title relative because it is actually a ratio. It's just a comparison between what is called the water vapor content of air, so how much water vapor is actually present in the air around us, versus the water vapor capacity, which is how much could the air theoretically hold at a certain temperature. So you have to think of air almost like a sponge. It can contain water vapor, right? It's water in the form of gas. We can't see it. If we could see it, you wouldn't be able to see anything at all because water vapor is all around us almost all the time. So relative humidity is calculated using the equation you can see here. Not something we've done any math with yet, but just to emphasize again that you're just comparing the content, how much water vapor is actually present in the air around us at any given time, versus the capacity, which is how much water, again, the air could hold at that temperature. And so if you think of it as a graph, which I've got drawn down here, there's a couple situations you could see. Most of the time, you've got a pretty high capacity, right? So let's say that that's how much water, it's usually measured in, I don't know, volume or something, how much water the air could hold, and content is usually lower than that actual amount, right? But you do end up with some situations where here's your capacity, and the content exactly equals it. That is what is called saturation right there, where you've got 100% relative humidity. In other words, the air contains as much water as it can hold, as its capacity can hold. So it's at 100%. That is what we refer to as the dew point. That's the temperature, right? So temperature can change this. Typically, as far as I understand, temperature is going to warmer temperatures increase capacity, right? So if it gets warmer, then the capacity might go a little bit higher. But colder temperatures will decrease the capacity. And what's interesting is if this happens where suddenly the capacity has decreased, the water content is also going to have to decrease to match that, right? If the air can't hold that much water anymore, then some of that water that was in the air is going to need to come out in the form of liquid again, right? And that is what creates what we see in the mornings as dew on grass or condensation on the surface of your car. That's because the air had a lot of water in it. Suddenly the air cooled down, its capacity got too low, and the water then is going to condense onto different surfaces. So we call that the dew point because it's going to form dew on grass and on other things, right? Any surface, right? So the temperature at which air is saturated, and therefore condensation occurs. So and it kind of makes sense that this happens in the morning, right? Because air spends most of the day absorbing a lot of water, and then at night temperatures cool down. So the air, the capacity lowers. Water is going to be deposited on things in the form of dew, right? Air reaches its dew point over the night and in the morning. So in the morning, when you go to your car or you walk around your yard, there's lots of dew everywhere. But by the afternoon, once the sun's out and things warm up, all that dew is suddenly gone again because the air has once again increased its capacity and therefore can take in more content, right? Can get more of the water up inside of it. So dew, frost, and fog are all forms of ways that the air can deposit water out of it, right? So when air reaches its dew point, it's saturated, water vapor condensation near the ground will appear again. I was talking about dew, right, which is just water vapor condenses onto colder surfaces, again, like the metal of a car or grass blades. If it's really cold outside, you can get frost, which is the exact same process, except that water basically is going to freeze, right? Deposits is kind of a fancy way of saying that it freezes, goes from vapor into ice form directly onto different surfaces. Or it could be fog, which is condensation in the air itself. And the way this works is the water molecules are basically attaching to like dust and ash and things like that that are in the air. And you think, wait, there's present in the air? It always is, right? I'm sure some of you have noticed this in your house, right? If there's a beam of light coming through, air is not clean. You can see it here. There's tons and tons of little tiny particles all over the place. And so water can actually condense onto those. That's what creates fog. So it's full of all those little particles. Not only fog forms this way, but clouds also form this way. When you see a cloud is liquid water in tiny, tiny little droplets that are deposited onto dust or ash or anything else that's in the air. So here's a good image to kind of drive that home a little bit, right? Smokestacks that you often see on power plants, like especially over at Moss Landing near where we are, That's not actually like smoke that's coming out. They're releasing water vapor. The water's been superheated. And so you'll notice there's this cloud right up here, but notice right at the smokestacks, there's nothing, right? It appears to be an empty space. And that's because at that point, the air is really hot, and so water vapor is still in its gas form. You cannot see water vapor. Clouds are not made of water vapor. If they were, they would be invisible. You wouldn't be able to see them. But as the water vapor moves away from these smokestacks and gets into the higher air, which we've learned is cooler, right? It's cold the higher up you go. It's going to cool down, and therefore it condenses onto little tiny particles that are in the air, dust, ash, whatever else is present, right? And it becomes little tiny water droplets. That's what we see. All this white fluffy stuff here is little tiny water droplets that are just floating through the air. And that is what clouds are as well. There's another video I can show you here just to emphasize this. This is really cool. So this is an airplane taking off in air that has reached its dew point. And so as the air is passing over the wing, there's something going on with the temperature and the pressure change. Anyway, the air is getting cooler over the wing, and look at that. You can see the water vapor, right? So the air is full of water vapor. We can't see it, but as it gets cooled down over the wing, suddenly it turns into clouds because it's condensing with the little tiny particles that are in it. I think that's really cool to watch. So, all right. So you had this formative assessment probe where students, 6 friends, were debating what clouds are actually made of, and the most correct description is Glenda. I think clouds are made of tiny drops of water or ice crystals, okay? Looking at each of these, Trista, large drops of water. If that was the case, we would be experiencing rain constantly. That's how rain falls. I think clouds are made of soft cotton-like material. Obviously not, else airplanes, when they flew through it, would stop or crash or burn up. I think clouds are made of smoke that rises up. Smoke definitely contributes to them forming, but you're not actually seeing smoke, else we would be smelling the smoke from the clouds. Made from evaporated water. This is probably the most commonly misunderstood thing in the form of a gas. Water vapor is invisible, okay? If this were true, you wouldn't be able to see clouds at all. And I think clouds are made of spongy material that holds water. No, that's the air, which again we can't see. And again, airplanes wouldn't be able to fly through clouds if they were made of spongy material, right? Water vapor is invisible. You cannot see it. So clouds are basically, as water vapor has risen and cooled, it condenses into liquid form. And you are just seeing liquid water condensed onto dust, smoke, ash, other particles that are up there, right? So they're made of tiny liquid droplets. That's what clouds are made out of. They're kept afloat because they're so small, and there's usually updrafts, right? There's air that is constantly pushing clouds upwards and keeping them suspended in the air at different elevations. So again, this just reemphasizes it, right? That clouds, again, water vapor has condensed to high up in the air and onto tiny little particles of matter that are present. And so again, clouds are made of tiny liquid water droplets. Often, sometimes also ice crystals, believe it or not, right? But it's not gas, it's liquid or solid water. And it's kept in the air by constantly rising updrafts that are just suspending the clouds. Okay, so there's many different cloud types that the chapter covers. I'm not really going to expect you to remember all of them. I would say the 3 to emphasize with kind of an additional 4th one I'll toss in. First one is cumulus, which are kind of low clouds. These are what you see often in kind of cartoon pictures of clouds, right? They're kind of these white fluffy things we see. Cumulonimbus, these are the storm clouds, right? They're vertically stacked, they're very tall, they're responsible for rain, thunder, lightning, hail, all that kind of stuff. And then cirrocumulus are just really high up ones that we sometimes see around here. Not usually though, they're more in colder environments. They're really high up, they're ice crystals, they look like little tiny white puffs. So here's your cirrocumulus, looking like little tiny white puffs, really high up. Here's your cumulus, which is the kind of what we all think of as clouds. Here's cumulonimbus. These are the storm clouds you'll see that are much darker in color. Those are what the source of rain, hail, lightning, thunder, that kind of thing. Here in Pebble Beach, we get a lot of this. The stratus, it's kind of almost like high fog, basically. That's what gives us that kind of constantly gray, uniform sky. Okay, let's talk about precipitation, right? How does liquid fall from clouds? This happens in a variety of different ways, but that's what the term precipitation describes. It's basically rain, snow, mist, drizzle, hail, freezing rain, sleet, all that stuff. And so I'll distinguish between 4 of these main ones, and I'll show a little video about each of them. So rain is the one we have all experienced. Tiny droplets are in the cloud. So again, remember, the cloud is already made of liquid droplets. They're just really, really small. Okay, so again, it's not water vapor. There's no condensation happening. That's already happened. The clouds are made of liquid. What happens is they kind of start to smash together, and they get big enough that that updraft, the air, can't hold them in place anymore, and so they begin to fall, right? The large droplets make the cloud much darker in color, right? You've seen those rain clouds that turn very dark gray, almost blue, and that's when you know rain is coming. Because they're much larger droplets and they're about to fall. Now again, you see this idealized image of raindrops look like that. Raindrops don't look like that because as they fall, they are experiencing air drag, and the air drag actually happens in the middle, and so it bends them into this kind of funny looking shape and often splits them into smaller rain particles. Raindrops are not uniform in size, so some are very small, some are very large. You can kind of experiment with this sometimes if you go outside with like a wet piece of paper and then run back on in. You don't see a uniform raindrop size. Snow is when those little tiny water droplets, which were high up in a cloud, have turned into ice, right? They freeze at very, very high elevations, and they form these beautiful geometric patterns, which we call snowflakes, and then those fall collectively to form that kind of very soft white ice form that we call snow, right? But again, very small, falls very slowly, very, very soft when it's falling and when it lands. Sleet, not to be confused with snow. Think of sleet as frozen rain, right? That's the main thing. That it's basically rain droplets, right? You can see them. Look how kind of neat and little round they are. It started to fall as rain, and it froze along the way. They often crumble too when they hit the ground, forming this kind of, again, this sheet of ice. But again, if you look at it very clearly, it's little tiny fine water droplets, right? So it's just rain that froze basically on the way down. That's sleet. Hail starts off as sleet, but now imagine that those little tiny raindrops freeze, but there's also a very strong updraft. There's air that's pushing them upwards, keeping them in the air. They encounter more and more water, and they get larger and larger, right? So you've got a tiny little piece of sleet that froze, but now suddenly it gets a little more water on it, freezes again, freezes again, freezes again, and suddenly you have what are called hailstones, which are much larger and can actually cause some damage. They can dent cars, break windows, that kind of thing. Here's a hailstone the size of a baseball, and usually that's determined by how strong the updraft is, right? So the stronger the wind is that's holding these hailstones up, right? The longer it takes them to fall, the larger they're going to be, and can be pretty dangerous. So just to show you a simple video showing you the different types of precipitation here. So yeah, rain is just little tiny water droplets that came from a cloud, right? So the cloud is already made of liquid water. Okay? I want to keep emphasizing that. It's just that those little tiny droplets start to condense together, right? They start to combine together into larger water droplets that the air can't hold up anymore, and so they fall in this liquid droplet form. Sleet is rain that froze on the way down, right? So it's basically the same little raindrops, but now they're in the form of ice. Note, it's not snow, right? This is still falling fast and quickly. It's not hail either. You're not getting these big giant stones that are bouncing everywhere. You're getting these very tiny, very fine, basically, again, little drops of rain that are frozen. So hail is sleet, but it was held up in the air longer, and they got really big. That's the absolutely enormous chunks of ice. So again, it's just rain droplets that were falling, but they were held up in the air longer. They explode into larger and larger hailstones. Those are falling and can be really, really dangerous. Now, snow is where the freezing happened high up, right? So notice this isn't like hail. It's not smashing things. Nothing's bouncing around. It's falling very slowly. So it was an ice crystal high up in the cloud already. And again, it's just like how rain, the water droplets group together to become larger. In snow, the little ice crystals that were making up that cloud condense together and form these heavier chunks, which then fall down. Okay, hope that was helpful. You've already read about that. So, thanks.